Hi, welcome back. This is section 2.3 in Math 0955, solving linear equations. So here is kind of the combination of 2-1 and 2-2. So you're going to be doing the addition property, the multiplication property, and some extra equations that we'll see along the way. Let's just dive right in and look at problem 1. So what do we got? 7x plus 6x minus 2x equals 4 plus 7. So in this problem, we want to start by combining like terms. Okay, so simplifying both sides of the equation, and then we'll start applying the addition property and the multiplication property as needed. Okay, so you can work two at a time. I like to record which guys I'm adding together, so otherwise it becomes a little confusing. So anyway, 7x plus 6x is going to be 13x. I'm just going to do two at a time. 4 plus 7 is 11. 13x minus 2x will give you 11x's. The other side I've got 11. And now I'm going to do the multiplication property. So in this case, division is required. So you just divide by whatever's in front of the variable. And 11 divided by 11 is 1 over 1. So that will be 1x, or just x. And then 11 divided by 11 on the other side, that's just 1. Right? So there are other options now. So you could have equations that result in no solutions or infinite solutions. And we'll see those as we go through some of these problems. Okay, so let's jump up to number 3 and see what we have in store. It's the same game as what we had in the previous problem. What we're going to do is combine like terms. In other words, simplify both sides, and then we will do the addition property and then the multiplication property. So firstly, on the left, I have a 5 minus 3x. So 5 minus 3 is 2x. And bring down the plus 7. And then on the right, there's an 8 and a negative 6. So 8 minus 6 is 2, and then plus 3x. Now you want to collect the variable terms on one side and the constant terms on the other. So it means use the addition property of equations. So here I'm going to first subtract 3x from both sides. 2x minus 3x is negative 1x. So I'll just write negative x. Bring down the 7. And on the right side I have a 2. Okay. Then I'm going to subtract 7 from both sides. And I have negative x equals negative 5. And then lastly, you need x equals something, right? So when you have these cases where there's a negative in front of the variable, you multiply both sides by a negative 1. All right, so negative times negative will give you positive x. And on the right, negative 5 times negative 1 is just positive 5. All right, so in question 4, you see some parentheses. That's going to indicate you have to do some distribution. Let's try number 6. So number 6 looks a little more difficult. Okay, so on the right, you see these parentheses. You want to do the distribution first. So I'm going to distribute negative 2 to both terms inside the parentheses. So it'll be negative 2 times x, which is negative 2x. So I'm just going to write minus 2x. And then negative 2 times negative 4 is positive 8. So I'm going to write plus 8. Once I've distributed, I'm going to combine like terms on the right side. So I'll have 30 plus 8 is 38. And then finally, I need to isolate the variable term. So I'm going to move the 38 over. 48 minus 38 is 10. On the right-hand side, I just have now negative 2x. And finally, use the multiplication property. So basically, whatever's in front of x, that's what we're going to divide by here. 10 divided by negative 2 is negative 5. Right hand side I have x, and usually we like to write that with the x on the left. Okay. Okay, so you go over there and plop it in. You can check your answer just by back substituting into the original equation. Let's see, so this is another distribution, and let's just do this number 7. It's kind of a more typical distribution problem because number 8 is going to be a little different. And so I think if we see kind of the standard operating procedure, you're not going to be misled when you see something that's kind of non-standard. And the problem is thinking that the non-standard is the standard, if that makes any sense. So, okay, so first I'm going to distribute. So 2 times 6z is 12 z's. 2 times 4 is 8, and then minus 9. So then 8 minus 9 is just going to give me minus 1. And then I'm going to add 1 to both sides. So I'll have 12z equals 108. Okay. Finally, isolate the variables. So I'm going to divide both sides by 12. And I end up with z equaling, let's see, so probably about 8. No, it's not 4, it's not going to work. 7, so it's not going to be a nice number, is what I'm hearing here. Let's divide the top by 6. So I'm going to divide top and bottom by 6. So in the top, it goes into 10 1, so 6, bring down the 4, so that'll be 18. And then all over 2, oh, that's just 9, so z equals 9. Sorry, made a big deal out of that, didn't need to. And let's make sure it works. Yay. All right, so this, as promised, this next one's a little different, right? Let's take a look at it. 8x minus 3x plus 4 is equal to 16. So here it's a little bit different because there's no number in front of the parentheses, right? So above at number 7, there's a pesky 2. Number 6, there's a negative 2. And you may wonder, well, what the heck am I supposed to distribute? There's nothing there, right? So the way you can imagine it is to re-envision subtraction as plus a negative number, right? And we're going to think of that negative as negative 1. So the thing you're actually distributing whenever you see that scenario is a negative 1. Okay, so I'm going to distribute that through. So negative 1 times 3x is negative 3x. So I'm just going to write minus 3x. And then negative 1 times 4 is negative 4. Then I have 8x minus 3x is 5x's, minus 4. And then we use the addition property to isolate the variable term. So again, the variable term is this guy right here. So I'm going to plus 4 on both sides. I have 5x equals 20. And lastly, you want to isolate the variable by dividing by whatever's in front of the variable. So in this case, 5. And I'll end up with x equaling 20 divided by 5 is 4. Okay. So the moral of this story is that when you see a negative in front of a parentheses, you're going to distribute a negative 1. Problem 10, we have distributions on both sides of the equation. There's another one of those. Let's go ahead and try number 12. Okay, so number 12, we have 3 times x plus 1 equals 7 times x minus 1 minus 18. So on both the left and the right side, you're going to be distributing this number first, and then you're going to, at least on the right, combine some like terms and then use your addition and multiplication properties. Okay, so first things first, I'm going to work on the left, distribute the 3. And then on the right, I'm going to distribute the 7. Okay. Then I'm going to combine some terms here. So negative 7 minus 18 is negative 25. Now I'm going to get all the variable terms on one side, the constant terms on the other. So I'm going to move the 7x over. Then I'm going to move the 3 over. Finally, use multiplication property. So whatever's in front of x, that's what I'm dividing by. Negative 28 divided by negative 4 is just going to give you 7. Negative divided by negative is positive. So let's put 7 in there and see what happens. Yay. All right. So simplify both sides first and then combine, like, you know, if simplification, it means distributing. It means combining like terms, and then once you've done all that, you're always doing you're usually doing the addition property and then the multiplication property. Okay, that order is important. You really can't mess too much with the order of things in math. It's the guidelines that make math what it is, right? So anyways, let's look at number 15. It looks like it's a lot of work there. There's all kinds of distributions. So 10 times z plus 4 minus 4 times z minus 3 equals 2 times z minus 4 plus 3 times z minus 4. Okay, great. So first, I'm going to distribute on this right-hand side. So I'll have 10z plus 40. I'm going to distribute this guy. Negative 4 times z is negative 4z, so I'll just write minus 4z. Negative 4 times negative 3 is plus 12. On the right-hand side, there is kind of a trick you can do here, which I'll just mention. You don't have to do this. And if it confuses you, just, you know, close your eyes. You don't want to be confused. So what I would do here is just, you could think of z minus 4 as a variable, you know. So it's basically kind of like thinking 2x plus 3x. And what does that give you? It gives you 5x, right? So it's really 5 times z minus 4, believe it or not. And then if you distribute, you get 5z minus 20. Okay. Okay, you can open your eyes now if you didn't want to be confused. So let's go ahead and do it the way I've been teaching, right? So I distribute the 2z, so you get 2z minus 8, and then plus, distribute the 3, so you get 3z minus 12. Start combining like terms on both sides. So here I have 10z minus 4z's is 6z's. And then 40 plus 12 is 52. On the right, I have 2z's plus 3z's is 5z's. And then negative 8 minus 12 is minus 20. Okay. So then I'm going to move the variables to one side, the constants to the other. So I'll start with the variable term. 6z minus 5z is 1z. And then I'm going to move the 52 over, and I get z equals negative 72, right? Okay. Let's find eraser. Okay, great. So let's move on, see what else they have for us. Okay, so here they have fractions, and whenever you see fractions, the method they want you to use is just to multiply to get rid of the fractions. Okay. In particular, they want you to multiply by the least common denominator of all the fractions involved. And in problem 16, there's only one fraction, so you're just going to end up multiplying by whatever's in the denominator of that fraction. The denominator is the bottom part of the fraction. So in this case, the denominator underneath that x is a 5. So what you do is just multiply both sides by 5. And it turns equation with fractions into an equation that's all integers. Okay. So let's go ahead and try this. So I'm going to distribute the 5. 5 times x over 5 is just going to be x, right? The 5 is going to cancel with the 5 that you're multiplying by, but I'll write it out. So you have 5 times x over 5. And then 5 times negative 5 is negative 25. And then the other side, 8 times 5 is 40, so we get a negative 40. Okay. The 5 times x over 5, that's just x, right? So the 5 goes in the 5, it's the same as 1 over 1, and then you just have 1 times x over 1 times 1, which is x over 1, which is just x. And lo and behold, now you have an equation that just has integer terms, regular numbers without fractions. And we already know how to solve this thing. So I'm going to add 25 to both sides. And I'll get x equals, I have to do a bit of arithmetic here, negative 15. Okay. Let's go ahead and check that the hard way. So I've been kind of lazy about checking. Usually I check in my head, so that's a good way to do it, but let's just see it. So I'm replacing x in the original equation with negative 15. So I have negative 15 over 5 minus 5 equals negative 8. Negative 15 over 5 is negative 3. And then simplify both sides. If both sides are the same, that means that it is a solution, so we will know with 100% accuracy that we have the answer. And need not worry about getting points deducted or whatever it is. It's really thinking about this one. Maybe it's wrong. Hello. Okay. Maybe there's something wrong with my internet. What's going on here? Let me pause the video and figure this out. One sec. Okay, there it goes. Sorry, I don't know what's wrong. Okay, so let's look at a slightly more complicated version of the problem where we have multiple fractions, and I need you to do the questions with fractions in this method. It's going to lead in later on to other things we do. So please, please, please do it my way. There is a method to my madness. If you do it your own way, I'm not going to give you partial credit if you get it wrong. Okay? Okay. So here I look at the denominators. The smallest number that's divisible by 5, 6, and 30 is 30. You can find other numbers like 60, but if you play that game that way, it's going to add complexity to the problem. It makes it harder. So what you try to do is find the least common denominator of those fractions, and in this case it's 30. You could still get the answer if you use the wrong common denominator. So if it's not the least common denominator, you can still get the answer, like if you use 60, for instance. So you don't have to worry too much, but like I said, it's going to make your life a lot harder if you don't use the smallest common denominator. Okay. So anyways, first on the left side, we want to distribute this 30. And the way I think of it is just 30 divided by 5 is 6, and then 6 times 4 is 24. And then 30, so that's the first multiplication, right? That would be this multiplication. 5 goes into 30 6 times 4 is 24. The second multiplication, 6 goes into 30 5 times, and then 5 times 5 is 25. So you get minus 25. On the right side, the 30s will divide out, and you're just left with 17. Okay. If you don't like to think too much with your brain, you can kind of write it all out and do the same operations. So this would be 30 times 4 over 5 minus 30 times 5 over 6. Here I have 17 over 30 times 30 over 1. So 30 over 30 is the same as 1 over 1. So you get 17 times 1 over 1 times 1 is 17. And then on the left, you can kind of put the 30s over 1 and do that game again. So 30 over 5 is 6, and then 6 times 4 is a 24. And the second one, 30 over 6 is 5, and then 5 times 5 is 25. Okay. Okay. Now I'm going to isolate the variable term. So I'll add 25 to both sides. So I get 7, 8, 9, 10, 11, 12. Carry the 1. And then 1, 2, 3, 4, 42. And then I want to divide to isolate the variable. So I have division by 24 on both sides. 40, and I'm going to divide top and bottom. It looks like 6 will divide into both of them. So 42 divided by 6 is 7. 24 divided by 6, I believe, is 4. And just go over to your answer box, plug that guy in, and you should be good. More of the sort of same thing here. Yeah, sure. Let's do one more, that number 19. Let's see how that operates. So I have 5x over 6 minus 10 equals x over 3 plus 8. I'm going to multiply both sides by the smallest number that's divisible by 6 and 3. So certainly 12 would work, but I want the smallest number, right? So I'm not going to use 12 because I think 6 would work. So yeah, 6 is the way to go. Okay. I'm going to write it all out rather than doing it in my head this time. So 6 times, I'm distributing, so 6 times 5x over 6 minus 6 times 10, the second distribution. And then on the right here, I'll have 6 times x over 3 plus 6 times 8 is 48. Okay. So on the left, I'll have 6 over 1. So the 6 over 6 is just 1, and then 1 times 5 will give you the 5x. 6 times 10 is 60. On the right, 3 goes in the 6 2 times, so you'll have 2 times x, and then plus 48. And finally, you're combining, collecting like terms on one side. So we'll have 3x, and then you're going to move all the constants to one side. And then finally, use your division to isolate the variable. Okay, so it looks like 36 is going to work. Let's try it. Yay. Okay, so in the next part, they have decimals, and the book recommends using multiples of 10 to get rid of the decimals. So if you have one decimal, you want to multiply everything by 10. If you have 2 decimals, they want you to multiply everything by 100. And what does that do? That just moves the decimal place, right? So if you have 2.5, and you multiply it by 10, it'll be 25. If you have 0.31 and you multiply it by 100, that'll just move that decimal place over 2 places. You get 31. So that's what they kind of want you to do with these these decimal problems. Let's try number 21. So I have 0.4x minus 8 equals 0.1 times x plus 10. So in this case, you can distribute first, or you can multiply by 10 first. I'm just going to multiply by 10 on both sides. Okay. So on the right side, 10 times 0.4 is going to just move that decimal place over and make it 4x. 10 times negative 8 is negative 80. 10 times 0.1, well, that's just 1. And then times the x plus 10. So on the right there, it may not be clear, but what's going on is you have 3 factors that you're multiplying together. It's the 10, the 0.1, and then the x plus 10. And when you have cases like that, you could just multiply 2 at a time. It's not like a distribution, right? So it's similar to thinking, okay, I'm going to multiply 3 times 2 times 5. So you don't multiply 3 times 2 and then 3 times 5, right? That wouldn't be right. It's just 3 times 2, which is 6, and then times 5, which is basically what I did here. I just multiplied 2 at a time, the 10 times 0.1, and then I have to multiply the result. So before that was 6, now it's 1, okay? And then distribute. Okay, so it's 4x minus 80. Distributing the 1, well, that's kind of silly. It's just going to give you x plus 10 again. Then I'm going to move the x, so minus x minus x. Trying to collect all those variables on one side, get all the constants on the other. Finally, divide both sides by 3. And we're getting 30 as our final answer. Okay, here's another one. This time you're going to have to multiply by 100. So we got 0.01 times x plus 12 minus 0.12 equals 0.01 times 7x plus 12. So again, I'm just going to multiply everything by 100. You could distribute first. It's not going to really disturb anything. Probably get away without having to multiply by 100 at all if you wanted to. I wouldn't have a problem with that. 0.01x, but it's a handy-dandy tool to have in your toolkit. You want as much practice as you can get here before they kind of throw you into the deep end later. 0.01 is going to, well, that's going to just move that decimal place over, right? It's going to make it into 0.12. Okay, so 12 times 0.01, that's just 1, 2, the decimal, yeah, so it's 0.12. And then minus 0.12 on the right. When you distribute, you get 0.07x. And then another, well, that's crazy, all these 0.12s in there. So 0.12. I'm going to simplify. So 0.12 minus 0.12, those will cancel each other out. I'm going to move the 0.07x to the other side. Or let's go ahead and multiply by 100 now. So I'm going to multiply both sides by 100. Okay, so 100 times 0.01 is 1, so this will just be x. On the right side, I'll have 100 times 0.07x, which is 7, and then plus 12. Get all those variables on one side, so I'm going to move the 7x over. End up with minus 6x, 12 over here. And then finally divide by negative 6. So we get x is positive by a negative is negative. 12 by 6 is 2. Type that in there. Yeah, so I mean, I guess it's really up to you if you want to go through the trouble of multiplying out by the appropriate factor. I wouldn't take off on a test if you just, left everything like this and then solved, right? So if you did it that way, it's going to be subtracting 0.07x on both sides. So you get negative 0.06x equals 0.12, and then you're dividing by negative 0.06 on both sides. And of course, you'll get the same answer, negative 2. If you go to your calculator, you may need to go to your calculator for the division there, but negative 2, and then check it. Row! I did something wrong. Oh, that's the wrong question. Sorry about that. Yeah, negative 2, I already put it in. Okay, what the heck is this thing? So number 23, we start getting into these problems where there might be no solutions, right? So when you get no solutions, what's going to happen is your variables will cancel and you'll end up with a false statement like 3 equals 2, or you'll end up with a true statement like 5 equals 5. When you get a true statement, it's all real numbers. When you get a false statement, there's no solutions, okay? So number 23, we have 3x minus 5. And you approach these in the same way you've been approaching the problems. You simplify both sides. And then you're going to try to collect the variables on one side. And when you do that, you're going to see that the variables cancel. So 3x minus 3x is 0. And you'll end up, in this case, we're getting a false statement, which tells me there's no solutions. Okay, so you just write no solutions, and then in the homework, you can just click on the appropriate bubble, and you should be good. Here's another one. Let's try maybe 25, see how that goes. So I got 7 times x plus 5 equals 10x minus 3 times x minus 4. Okay, so clean up both sides first. I'm going to have to do some distributions. So on the left there I have 7x plus 35. Breathe. Always trying to combat anxiety. And the way they have me doing it now is apparently they've done all kinds of research that says if you focus on meditation and breathing, it's supposed to help your anxiety. So I try to remind myself to breathe, because I guess a lot of times those feelings of anxiety come from you not breathing correctly. So you get scared, you may start breathing more shallow. So I just remind myself, if you're wondering why I breathe, I'm reminding myself to breathe. I'm trying to work my way through all these anxiety issues that so many of us have these days. But anyways, negative 3 times x is negative 3x. Negative 3 times negative 4 is plus 12. And I combine like terms on both sides. So I have 7x plus 35 plus 5 is 40. On the right, 10 minus 3 is 7. Okay, so it's just business as usual. And now I'm trying to collect my like terms together. And I don't really overthink it. Like, I know some people will kick back and say, well, that's no solutions, but I kind of try to take my brain out of it, because a lot of times my brain will, especially if I'm tired, it'll mislead me. It'll tell me that you found the answer just so I can sleep. It's crazy like that. So it tried to remove your intuition, I guess. Mathematics is not about intuition. I mean, sometimes, yeah, but a lot of times, no. You want everything to be kind of like a computer is doing it. So anyways, here I get a false statement again. So 40 is definitely not equal to 12. So therefore, there's no solutions. Okay. All right, so no solutions there. Yay. And, you know, this is so on and so forth is one of those problems, but there's fractions involved. Sure, let's try this one. It's got a variable b. You don't see that very much. B as in baseball. So b is 7 minus 11 twelfths times b. So the first things first, multiply by something that's divisible by 6 and 12, and that's just 12. So multiply both sides by 12. Okay, so on the left, 6 goes in the 12 two times, and then 2 times 5 over, 1 times 1. It's going to give you 10 b's. On the right, I'm distributing, so I have 84 minus, in this case, the 12s will divide out, just leaving you with 11 b's. Then I'm going to try to combine the variables on one side. This one looks like it's going to work. 21b is 84. And then finally divide by 21. So it looks like v is equal to 4. This is 4. Yay. All right. So then we're getting into our lovely story problems here. Let's try number 29. That's one of the weird ones where you don't really do it in order. So it says when 3 is subtracted from 3/10 of a number, the result is equal to 1/5 of a number. So again, the pitfall is interpreting this one directly in order. So the only time you really have to change the order is when you're dealing with subtraction or a minus. Those subtraction ones you got to watch out for. So here it's 3 subtracted from 3/10 of a number. So what you're not going to do is write 3 minus 3/10 of a number. That one, no, you got to change the order, right? So it's 3/10, and then you're taking away 3 from that item. Okay? And then they say the result is equal to 1/5 of a number. So that word of, you want to think of that as multiply. Whenever you see that, it just means to multiply. Okay? Okay, so now they probably want us to solve it. They want us to input it first. Okay, hold on. I really try not to use those little buttons at the bottom there. I just use the shortcut keys. So for a fraction, it's the bar thing. It's the other way. See how I typed it? It's the other one though. The one by the question mark symbol at the bottom of your keyboard. Okay. If you hit that, it'll automatically give you a fraction. And then you can just type in with your arrow keys. So I use my arrow keys to go up and down, and then over to get out of the fraction, and then minus 3 equals, and then in our fraction, 1/5, and then x. And then we're going to multiply through by 10 and solve. Okay, here we got some sort of formula problem. Let's take a look. So I'm going to write down the formula first and then define the variables. So F is the cost for driving X miles per hour over the speed limit. So there's about 5 tickets, I guess. X is number miles over speed limit. Okay. So in this problem, it says use the formula to determine how fast a person is speeding. So that's the X value if the fine is $180. So they're basically telling you F is 180, find X. So you substitute that 180 into the equation. I'm going to distribute this 5. then combine your like terms. I think that's 195, right? 250 minus 50 is 200, and then minus a number, another 5 is 195. Okay, I'm going to add this to both sides. Seems like he's probably going pretty fast, right? And this is just the number of miles over 50. Really? I'm dividing both sides by 5. Oh, jeez, is he going 120 miles per hour? No, this is not making sense, right? I must have done something improper here. Let me just sit here for a second and try to figure out what I did. Did I copy the problem correctly? Yes. The person was fined $180. Oh. So, I don't know, maybe it's correct. Okay, 35, 25 is 5. So apparently 75 equals x. It's the number of miles over 50, really? Let me figure out what x is supposed to be. No, it's just, sorry, I thought x was supposed to be the number of miles over the speed limit. It's not, it's just your speed. That person was cruising. All right, so this person was going 75 miles per hour. And you should always write up your story problem answers using English. Don't start your sentences with a number. So here is a chart problem. We have another model, so let me write down the model. So the mathematical model, W over 2 minus 3h equals 53, describes a healthy weight range for a person whose height is h inches over 5 feet. And what else? Use a formula to find the healthy weight. So I guess W is the healthy weight. For somebody of that height. Okay. Use the formula to find the healthy weight of a person who is 5'4". Okay, so if the person is 5'4", that means the h value that we want is going to be 4, because it's the number of inches over 5 feet. Right? Okay, so I'm going to put 4 into my equation for h. So I have W over 2 minus 12 equals 53. This time I'm just going to move the 12 over rather than getting all carried away. So I have W over 2 equals 65. And then I'm just going to multiply both sides by 2. So W equals, I believe, 130. The weight is 130. It's a healthy weight. The formula value for the healthy weight is, oh, so they want to compare it to the actual data over here. So the lower end for a 5'4" person is 111. So they want to know how much this is over 111. So you just subtract 130 and 111. So it's 19 pounds. Okay, and then this one looks like it's about scuba diving or something. Very interesting. Okay, so that'll be good enough for me. Hopefully this helps a lot or a little, and see you next time.